All right, so welcome back. We are now, if you look at your assignments, we're well past halfway in this class, and we're now in week 11. So we're going to look at some items in week 11, and we're going to look at last week's assignment and give you some hints and tips. And one of the things when I looked through here, a lot of you made a program that worked, but it lacked a couple of features. And one of them that people did is they didn't put both halves of this in there. So half of the problem was adding a scoring system, half of the problem was adding a hint function. So if you did one or the other, your grade will reflect that. And the other problem we have is that idea of scalability. So we're going to show you some ideas about how you can create this and make it a scalable solution. So you wrote a really quick program. It's got 5 or 7 or 8 words in it. You could do that with a series of else and elif statements to do your hints. That works for 5 or 8 or 10 words. If you decided, I'm going to put in 500 words in a list, that solution isn't really viable. It doesn't necessarily work. So one of the ways, and I've kind of got this stripped down, so there's a few pieces I want to make sure we're not missing here. But let me show you one example here of an alternative method to have done this. So, File New. All right, so a couple of things. Notice I stripped out. Up here, it needs to have your name in it, and I had several people, again, forget to do that. And this particular problem also doesn't have a input at the end. So if I just ran this in a normal utility, it's going to have an issue. So let's take a look at this one a little bit. And I want to look at this possible solution and what difference or a way that it works. So we know that we can create this thing called a tuple. But what's interesting is a tuple can also contain groups of items, so you're essentially having a group of items inside another group of items. And so in this case, this person modified their tuple. So notice here we linked Python with its hint directly. So Python, comma, what is taught in CMIS 210, comma. And notice those are in parentheses. So each one's in another set of parentheses. And so what it's doing now is it's created a tuple, and each tuple then has 2 items. Each list item in there has 2 items. And so here we're going to create our word list, and notice here we take out word and hints both, so Python and a hint, using that random choice. So that one works directly. So we make our list up. And again, we could use some white space in here to make this a little more clear what we're doing. And Python doesn't care about our white space this way. So this would be far easier to construct a game than that you had 500 or 100 or multiple words. So and this one then also adds a scoring feature where you have a score minus 10 and different pieces. So it actively created a scoring system so that you have a way to tell your users what happens. So, and I will post these up as some samples so you can look at them. So this one says, here's your word, here's how our scoring works, enter your guess, and remember there's no crying in this game. So it gives us an example and goes through and does that. File New. So the way I would have probably done it is closer to this sample, just because in a lot of other languages we don't have the ability to manipulate those tuples or arrays like we do in Python. So in this particular version, we actually set up 2 arrays. So notice we set up one array called words, And then we create a parallel array called hints. And so Python is matched with code, snake is slithery, jumble is scrambled, easy is opposite of hard. And notice again, we have two distinct lists up here. What the hard part in this is, the way that your code was originally structured, you have to come up with a way to tell what word it is in here. Because you randomly pick a word through here. You don't know its index position, and that's how you match those two arrays, is by this index position. But we used random choice. So in this particular case, we've changed it just a little bit. So the first thing we did is said, all right, word list equals length. So we figured out how many items are in here. And then we said index is equal to the random rand range of word list length. So in other words, we took the length of this item and took a random variable out of that to pick both the word and the hint. And since they're the same, then we have a match up there. The rest of this is very similar, but they have a score. And so if you look through here, they have score equals score minus 5. So again, they started with an idea that if you took a hint, you lose score points. So again, this is another way we could have done that and done something very similar to. So I have another example I'd like to show you. So this particular one, this particular model does the same thing. It says has a words and a hints feature. So again, we have that matching tuples that we can match the indexes on. But this one to pick it does something very similar. It says, all right, pick equals random range of 0 to 5. So they've counted the words. So it's a little less robust. I can't just add words in there without changing that value. So that I just wanted to show you that example of this being far more robust, because if I just add words in there, it's automatically going to take care of them. So it's scalable and it's robust. This one I can add words in there, but they're not going to get used for anything. Only those values that are in there already get used. So there are some additional ways we could have done this. So there is an index function. So I could have used index. So once I used my word random choice, I could have used an index function to find out what position that index is. So these problems, as we start going, are going to get not necessarily harder, but you're going to have more and more choices to make in how you do them. In fact, this particular model, the other thing, this particular one that I thought was interesting, it's not as robust here because, again, you manually entered how many those are, and you could certainly change that with a couple of lines to fix that. But it also put the entire game, notice, here in a loop, and so instead of ending the game, it asks if you want to play again, and it actually comes around and lets you play the game multiple times. So just an interesting change and a different way to approach this a little bit. So I will post a couple of samples up, and then as we go through there, we can see. So again, those elifs aren't necessarily a wrong way to do it, but it doesn't lend itself to the ability to change things very easily and add in the future. And so I saw quite a few people that chose to do the elifs. And again, that works. 10 questions, it works. You could do it with 100, but it starts getting pretty awkward when you could do something really clever and do these paired tuples. And we use those a lot. So think about all of those records you have of you as a person. So first name, last name, student ID, NUID, all those kinds of things that we want to pair up, we can do that using our idea of tuples. All right, let me find a new one here. Blank new. And let me grab the right week. So this week we're going to add a couple more pieces into our data structure. So we're going to jump in and we're going to talk about things. We're going to have to add lists and we're going to add dictionary functions. And I did have a couple of people that looked ahead and they used a dictionary data type for this particular problem. So there is a difference between a list and those tuples. And we'll show you what those are. And one of the biggest differences is I can change things inside of a list. So grab my documents here. So we are doing chapter 5 out of the textbook now. So those tuples worked really well. The biggest problem we have with a tuple is we can't change anything in that tuple. We can recreate the entire tuple, but it would be great if we had a structure similar to a tuple, but that we could grab one element out and change it. So think about our last chapter. We used one that had a list of items. So we created like a Dungeons and Dragons game. You had a list of things you were carrying. Now we want to change that up a little bit. So we can use something called a list, and we can create this idea of a list. So I'm gonna create a program here using lists. So we're gonna demonstrate lists. Demonstrate lists. And you're going to see that lists look a lot like what we're used to. So I'm going to create a list called inventory. And that inventory list is going to be similar to what we did before with the tuples, but one small difference. So instead of a parenthesis, I use the square bracket. And I can put several items in there. Maybe he likes to take pictures. Maybe he needs a potion of healing. And maybe he needs a blanket. And notice when I put them in the square brackets, instead of a tuple, I've created a list. That's the only difference. It's still a data structure. It still does exactly the same items. I can retrieve it and work with it the same way. But it's more powerful because we're going to be able to change it. So I'm going to print the items in there again so I can use that for loop. So for item in inventory. So the very same things are going to work. Print item. And so I can save this. Let's run it. It's going to make me save it somewhere. So documents, Python, inventory 3. And so I misspelled print. Great. Nice job. Inventory 3. So go back, fix my message. There we go. So now it goes through and it runs out. So it does exactly the same thing. We can do the same thing where we can check what's inside of an inventory. So I can ask questions. So we could do the if blanket in inventory. Bless you guys. You guys are all sneezing today. You will sleep warm at night. So I can run that. And notice it goes through, it checks through there, and we can condition those. We can index those positions. So we can do something very similar. We can print a specific item in here. So if I want to print only an item that's at some particular index number, so I could print inventory. Now notice I have to use the square brackets to call that index position. So I want to print what's in position 2. I can do that. And so notice it printed potion of healing. I can do the slicing the same. So everything we could do with a tuple, we could do the same. We could do the concatenation. We could put two lists together. So we could concatenate two pieces together. So all of the same things. But what is different about this, is I can actually change something. So I can change something. So I'm going to say change item. And so I could print up and say what I'm going to do. I am going to trade out my blanket. Maybe it is now summer. Don't need a blanket. So I could say inventory and a position. So our blanket is 0, 1, 2, 3. We have 4 items in our array, but it's the item number 3. And I'm going to say that's equal to, maybe we're going to trade it for an air conditioner. And now I'm just going to copy this for loop up here, and we can print our inventory again. So, at first, sword, camera, potion, blanket. You will sleep warm at night because you have a blanket. I could pull out an individual item. I'm going to trade out my blanket, and now my list is sword, camera, potion of healing, air conditioner. So the biggest change then is being able to trade out one item for another. And in fact, we can change out entire list of items So I could change out not just one item, but I can do a list of items. So I'm going to actually put it up above here. And so I could say inventory, and using those colons, I could go from 2 to 3 or 4 or whatever I want to do, is equal to I'm going to change those all to fans. So now, let's take a look at what happens and what we're going to do in this particular one. So we're changing those, and notice it's sliced out index position 2 through 4 and replaced it with the word fans. So, well, that's interesting. Let's try something different. Let's see what happens if I do it in position 0 to 3. And notice it says fans and air conditioner. That's the only thing left in my inventory. It sliced it out and replaced it with a single entry. So we can manipulate lists, or sometimes called an array, all over the place. So we get that ability to move things around. Now, one thing we might want to do is I'm going to add an element to this array. So right now, if I printed out the length of this array after I do this fan, and we can do that. So we want to print length, and we want to print that length of our array. We could do that, and we could see how long does it think this array is now. So I am going to grab, so we could print length of, come back here, array, which is inventory. And again, I didn't make it pretty, but we can see what happens. So we know originally what that went to. Oop, what did I do? Something weird. Way too many windows open down here. Oh, duh. Print length of inventory, chunk. So now, and I know it's hard to see because it went all the way down on the bottom. Make that a little smaller. So now it says I only went to 2 items. So we got rid of items. Using that slice, we sliced it out and replaced it with a single item. So we can manipulate this all over the place. So if I only have 2 items down here, I want to add another item. So I have 2 items in my array. My length is, so I have position 0 and position 1. So fans and air conditioner. I want to add another item. So I'm going to say then inventory and position 3, I'm going to set equal to ice cubes. And, uh-oh, we get an error. We have changed that list to only have 2 items. I can't add an item at the end of it. So it's kind of an odd thing. I can use the concatenation and I can add a new one, but I can't directly assign one because we've already shrunk that list to only have 2 items. So when I try to put something in position 3, it says, nope, no go, we can't do that. So we can't add one directly, but I can do this. I can actually delete an item in inventory. So let's try this. And using the key phrase delete, inventory, let's delete out the one in position 2. Oh, actually be position 1. And then I can print out that length and the list of items again. So the only way to get comfortable with these is we need to try that. And somehow I missed something there. Inventory. Oh. Inventory. It would help if I could spell. So now we took it down to 1 item, and the only thing left is fans. We deleted that. So we can delete things out. We can change things, and we can use that concatenation to add things into our inventory. So we're going to actually create a high scores program. And this one's kind of fun because we're going to actually use some of these techniques as we go through other codes and other programs. You can use the same thing in here. So I'm going to get rid of a bunch of this junk. Chunk. Nope. So we can start over with a clean slate and a clean window. So one of the things you were tasked with last week was creating a new file. There we go. You were tasked with creating a high score program. Well, you can add some of these steps in here. So this one's going to just keep track of our high scores. So high scores. And this is going to show us list methods. So I'm going to create a list called scores. And I'm not going to put anything in it yet. I'm just going to have a blank. So I use the square brackets, and that tells me, great. So I'm also going to show you how we could create a menu structure, because this gets to be really a useful thing. And so the first thing I'm going to do is our menu is based on an input of a choice. So choice, we're going to set equal to none. And again, if I start with a capital letter and it turns orange, that tells me that I've done it right, and I'm going to put everything in a while loop. So while choice does not equal 0. And notice what I did here. I put 0 in as a text item. If I just put 0 in as a number, we would have to convert your input into an integer. This way we're just going to compare kind of, if you want to think about it, the raw input to what the computer would think it is. So we're going to have that equal to 0. And so everything underneath here is going to be in an indented block. It's going to run in that while loop. So I'm going to cheat a little bit so I don't have to retype this, because my typing scores are really bad. And I am going to type in a print statement. And that print statement lists our scores and our options. So we have 4 different options that we can choose from. So we're going to say choice is now going to be equal to input. Please enter your choice from the list above. So now everything you do is going to be in there. And we could do a print statement just to kind of move it down, make life a little easier. Well, we need a couple of those choices. So what I'm going to do is, the first thing I'm going to do is I'm going to block them out by area. So I'm going to say exit. I'm going to say, what is our next choice? Show scores. Add a score. Remove a score. Sort scores. So each one of these groups now I can say, all right, I know what I'm going to do. So in this particular case, in the exit group, at that same indent, I'm going to put my if statement. So if choice is equal to 0. So they typed in 0 for exit. I'm just going to make a print statement, and I'm going to say, thank you for using our product. So it's not going to do anything else except run that print statement, and then it's going to exit down through the loop. When it gets to the bottom of that loop, it's going to come back up here, and it says, oh, while choice is not equal to 0, so if they put in 0, it's going to exit that loop. So the only thing that's going to happen is it's going to print this particular statement. So if they put in show scores, which is 1, so now I'm going to use, this is a case where I'm going to use those LS, so choice is equal to 1. Now notice I'm in another indent, and I'm going to print, this is a list of high scores. And then I'm just going to run a for loop. So for score in scores. So notice I used a different one, but it's a variation, so it makes sense. So our scores are stored in here. I'm temporarily using the variable score. Print. It should be indented. I'm not sure why it didn't. Here, chunk. First score, end scores. Why are you not indenting? All right. So print scores. So I've got one choice, I've got two choices. So this one, nothing different. We're gonna print one. Well, we need to add a score. So we're going to use another LF. So LF choice is equal set up to 2. So now we have a second choice, and this one's going to be adding a score. So this is the first of what we're going to call these dot notation or the methods, something that's included in here. So we're going to do something interesting. So score is equal to, and we're going to get an input. What score did you want to add? So that would work. That would get a score, but it would be a character or a non-math-based number, not an integer, not a decimal. So it's a varchar, a variable character. So I'm going to do an input. So notice I'm going to change it to an integer right there. So now we take whatever they put in, and it's going to change it to an integer. So now I've used that score, my little temporary variable holder, and now I could say, so scores is our entire list, dot append. So append says we're going to add to that, and then I'm just going to add score in there. So easy way to do it. There are other methods. We could have went in and added another second list, concatenated them together, but notice that we can just say scores.append. And so scores.append is really a kind of a handy way to do that. So we want to remove a score. So one of the things I'm going to do here really quickly, notice I'm just going to copy this because this is the class that I will encourage you to copy and paste. So I'm going to go back to the right line. I'm going to paste that in. And now I'm just going to change one number to 3. So if it's equal to 3, now I'm going to remove a score. So very similar type of thing. So in fact, you could take this and grab this line here, because we're going to use that same variable. We're going to get an input, and just change that text. So I'm going to change from add to remove. Make life easy for me. So I get a score, and I'm going to remove a score. Well, I want to make sure that is in my list, because if it's not in my list and I try to remove it, I'm going to get an error. Well, we know we can do that really easily with that if statement. So if score in scores, so if it exists inside of my if it exists, I'm now going to remove it. So scores dot remove. All right, so append and remove. And so notice I'm going to look for that value score, and I'm going to remove it. Well, as an error trap, I'm going to add an else in there. Else, and I'm going to say print that score doesn't exist in your list of scores. So, and you could make it prettier. You could repeat it back to them. So you could say the number you entered, and that way you can reinforce that maybe they entered the wrong number. And then the last one I want to look at is we want to be able to sort our scores. So in this particular case, we're going to do an LF, and now we're going to say choice equals 4. So we've got our last choice. And in this particular case, we can use a sort method. So scores.sort. And then we're going to say reverse equal true. So what that does, normally I would sort something and it would go from lowest to highest. But when we do scores, do we want to show the lowest to the highest, or we always want to do the highest to the lowest normally? So if I just say reverse equals true, that says we do want to reverse it. And we'll show you in the book, there's a chart here. So if you look on page 132, at the bottom, there's a lot of these methods. So we can do an append, we can do a sort, we can do a count. So an account is how many times a particular score would show up. So if we had a giant list of scores and we wanted to do something where we wanted to see how many times somebody scored 100 points on a quiz or something, we could do that very easily. The interesting one, I think, is something called pop. So if we pop, we return a value and remove it from our list. So that's kind of an interesting one. So we could do the same thing. We could get the value and then use the remove, but it's a two-step process. So this gives us a really quick, easy way to look at scores. So if I ran this, so here we go. We want to add a score. So the first thing we're going to have to do, unfortunately, is we're going to have to add a score. And I'm going to add a score of 98. And I'm going to add a score of 87. And I'm going to add a score of 104. So now if I show all these scores, it's going to list them 98, 78, 104. All right, it's got our scores in our list. Let's see if sorting actually works. So now we have to list our score again. So it might be handy to add the list right after you sort. So you could certainly add that in there. So I want to show my scores now. And notice it's now sorted them. Well, I realize that 104 isn't possible, so I'm going to remove a score. And I'm going to remove 102. 102 is not in the high score list. I typed in the wrong number. I'm going to remove 104. And now I'm going to show the scores. So now it just scores 98, 78. And this program can take a ton of these. I could add a score of and it will show all of those. And so it's going to show all the numbers. I can sort that and show them. And so now it'll score all of those. Now, clearly I can see I have some scores that probably don't belong, but it gives me a really great way to do that. So the other piece I want to put in here, so I have my LF for my last choice. I usually want to put in some kind of error trapping. Something to say, you know what, I have if, I have LFs, and if I do an else, so any other condition is going to catch an LF, and I'm going to say, you know what, your fingers must have typed incorrectly That isn't an option. So this is just an example of that arrow trapping. It makes my program more robust. If we get an error, instead of just crashing, it actually handles it and comes back and runs. So we can see that. So if I typed in the option 6, it says, nope, that's not an option. Or I typed in A. So as long as it's anything in there, it's just going to error out and continue looping. It's not going to crash. So it's an idea of that, how do I create things as scalable as possible? So page 133 talks about lists versus tuples. And there are times when we use one or the other. So the biggest things that are tuples don't allow you to change, and sometimes that's a great idea actually in coding. We maybe don't want to change something. They're also significantly faster. And honestly, with the number of scores and things we have in here, it doesn't make a lot of difference. But if we had 1,000,000 entries, it would make a difference in how quickly something actually works. So, we want to change our scoring program, and we want to keep track of something else. This scoring program works well, keeps a list of our scores, but it doesn't tell us who got the score. And so maybe we want to create a scoring program that will not only keep track of who got the score, but what their score was. So we can do a nested index. So nesting is just another way we can put things together. So I'm going to take my original program here, where I have it, and I'm going to change it just a little bit. So I'm going to edit this, because we've got a lot of the pieces we already want in there. And so I'm going to take out a couple of items. So all I want to do is I want 3 items. I want quit or exit, I want a list score, and I want an add a score. So list score, add a score, everything else we're going to take out temporarily. So I'm going to delete that out of my comment code. My choice, my input's going to be the same. It's not going to necessarily change. So that doesn't change in me. My exit isn't going to change. My show score is going to change just a little bit. So what I want to do is I am going to change that scores just a little bit. So still going to have, it's still going to be a list, but I'm going to nest some pieces in there. So now I am going to do something a little different. So I wanted to do this. Oh, let's see if I can do this real quick. So I'm in the right one. So what I want to do is accomplish this. So I want to list a score. And right now it's not going to show me anything because we haven't added one. So let's add a score. What is the player's name? Bob. What player, what score did he get? 100. I want to add a score. So Mary. And Mary got a better score. She got a 140. And now I want to list those scores. Oop. Well, I want to add another one. So Mark only got a 21. All right, so I want to list a score. And so notice now it says, oh, here is name, here's score, Mary, Bob. So it's a little more useful. So we're going to have to change some of our elements. So we can get rid of remove a score and sort scores because we're not doing those right now. Our else is still going to be the same. So show scores is going to have to change just a little bit. And show scores, we're going to change, so this is a list of high scores. and we're going to have to put in print, and we'd like to put in a title up there, so maybe name, so a name, and then we're going to use our tab function, so we jump it over a little bit, and then score. And we're going to do the same thing. So we're going to do a for loop. But now we need a couple of different pieces. So for score and scores, well, now we need two different pieces in here so we can print them. So this is where it gets a little tricky. So I'm going to change this name to entry. And because we're nesting these scores together, we know we're getting a score and a name. So at the same place here, I'm now going to say score, comma, name is equal to entry. So entry comes in and grabs a score and a name, and now we split it out into two separate variables, and now we can print score so, or whatever reason, we did name, sorry. So name, and then we're going to put in our tab character to move it over to the same line, and then we're going to do score. So that part doesn't look that much different. When we put our inputs in, though, this is where it's going to change just a little bit. And so we need to change this one a lot. So I'm just going to delete this for now. So choice is still the same. So now we're going to say we need a name, and that's going to be an input of please input a name. And we're going to end our input. And then we're going to ask for score. So score equals input. Please enter a score. So we're just showing how we can nest those elements together. So entry then becomes, so now we're putting those together, so we're nesting those together, score and name. And now we do scores dot append, and we pass in entry. So we pass both pieces in. And at this point, we'll sort it also. So scores dot sort, and we're going to say reverse equals true. So in other words, so it will append them. And manipulate them there. So, and then we do something else interesting. That slice function we can use. We can do that to also eliminate entries. So maybe we want to list only 5 entries and keep them in our bank. So the top 5 scores or the top 10. So we're going to use another a function, scores equal scores. And we're going to use that slice function, so colon 5. So we're going to slice through 5, and then we're going to drop everything else. So this is going to eliminate all but the top 5. So we can try this, and we can see, does that really do what we think it does? So I'm going to list my scores right now, see how many I have. And right now I have 3 scores. So I'm going to add a few more and make sure that that actually works. So I'm going to add Luke. And Luke got a score of 156. I'm going to add a score Zach. And So that got a 141. And so now if I list them, I should have Luke, Zach, Mary, Bob, and Mark. So I've got 5 scores. I'm going to add another one. Add a score, so I'm going to add Jackie. And Jackie got a 39. So now if I list those scores, I should expect that Mark is no longer on our score list. So here he is at number 5, and here we've sliced him off. So it's a really handy way we can keep track of those then. And we can do those. So, handy tools to build. We know how to build a menu structure now. So you could build your entire program in a menu structure. So the key to this is those indents. If I lose track of the indents, then I can oftentimes have issues. So I got to make sure that my indents are working properly. So here in this while loop, everything in this while loop is at an indented level. And so once it exits out of that loop, then it'll drop out and run out to the bottom. So close, no, don't save that. So that's a system that we could do a lot of different things with. So now we can sort things by alphabetical order or reverse alphabetical order or by numerical order. So a couple of things to keep in mind when you're sorting. So if I'm going to use that sort routine is case sensitive. Well, what I mean by that is if I have a list of items, and instead of sorting these by score, I'm sorting a list of names. And I want to put them in alphabetical order. A lowercase letter is different than an uppercase letter. And so remember, we have those dot lower, dot uppers. So I can transform variables so that I can actually score them correctly when I'm doing that. So we want to look at one more type of element in here. So we've got tuples now, and we know tuples are similar to a list. So lists and tuples are similar. Tuples use the parenthesis. Lists use the square brackets. Lists can change. Tuples cannot. We can manipulate around a tuple and pass it into another one if we need to add things, but we can't change an element directly in a tuple. And so normally that's a bit of a problem. So we have one more type of data that we can store in these list tuple structures. And let's see, file new. All right, so I'm going to call this one my Geek Translator. And so this is going to introduce an element called the dictionary. And again, I did have, I think, one or maybe two people were looking ahead, and they actually used this to solve their issue with last week's problem. So a dictionary then, so here we're going to take and we're going to create a data structure called Geek. And that data structure is going to look like, bless you, it's going to look like some of these others, but instead of the square brackets or the parenthesis, I'm going to hit the Shift key and use that squiggly bracket above there. And that squiggly bracket says, all right, we're creating a dictionary now. And so I'm going to create the first word in my dictionary. So I'm going to use the term 404. Well, 404 is a web page that won't respond and won't show you an answer. But notice what I'm going to do. I'm going to put a colon in, and so I put the term, and now I'm going to put the definition in of. So the definition, at least from our book, is that you're clueless from the web error message 404, meaning page not found. We all know people like that. So now I'm going to separate that with a comma. So I'm going to put a comma, and I'm going to hit the Enter key, and we can actually create a list of these then very easily. So maybe we have uninstalled. So uninstalled is the term. I'm going to hit the colon, and now I'm going to put in the definition. So the definition is being fired. So some of these are kind of harsh. So maybe I'm going to put in the word nerd. Bless you guys. It's like it's spring allergy season. So nerd is nerdy. So I end it, and I'm going to put in that ending bracket. So now I have, in this case, I created a dictionary with 3 elements. So an item or a pair in there, we can address then. So if I just address this directly, I can do that. I can say I want geek or I want 404, and I can actually get that really, really quickly. That's nice. So let's see what other things we can do with this dictionary and see if we can figure out what's going to happen. So I'm going to create a menu. This menu structures are we're going to use in almost all of our programs at this point. And so again, I'm going to do the choice equals none. And so notice that menu that we used before, I could actually reuse it and reuse some of those items. So because I've done that, notice now I've created a menu. So while choice is equal to none, those things are used all the time. This print statement, you could just modify it and reuse it, that triple quoted string. I just went ahead and stole that. We know that almost all of these, has that one got a choice? Yep. So we know that the first thing it's going to do then is we have to input a choice. So I'm going to copy. So we input a choice, and then we can go in and we can put in our individual elements. So we know that the first one is always the same in our menu. So we're creating kind of a consistent menu structure. So the first one's going to say, if choice equals 0, exit out of the menu. So we know the other thing we need at the bottom of our program, at that left indent, is this statement to hold our program open. So we know we're going to have an elif. And so elif choice equals 1. And so if I have all this already set up in another program, I can just grab it and use that menu and modify it to my needs. So the first choice in this is look up a geeky term. So the first term, so we could say term equals input. What term do you want to look up? So we get an input. Well, just to trap errors, we're going to use our if statement. So if term in, but maybe there's an even better way. Maybe we can use it to look at that. So if term in geek, so we're going to check and see if it's there. If it is, we're going to print a definition. But we need to get that definition. So we're going to ask the question, if geek or term is in geek, then definition equals the value of geek, and we can pass directly in term. So we don't have to look for an index position. We can actually just say based on that item you put in there. So I'm going to save this. See where we're at time-wise. So I'm going to say geek translator. Save it in documents, Python. And I'm going to run it so far. Now, it's not fully built. So there are things that aren't going to work. If I said 4, it's going to break. And in fact, it really weirdly breaks because it's still been running the other program. And notice, I just got an answer for something interesting. Notice that it's crossed that line between the two of them. So let me run it again. And I want to look up a geek term. And the term I want to look up, because it's easy to type, is 404. It's going to pass that in and say clueless. From the web server message error, blah, blah, blah. So I know my program works, but notice when I asked something out of bounds, it still tried to do it, which is kind of weird. So I'm going to go back to my original program here. And so now I know that we can do the choice 1. It does pull the definition. So I want to be able to add a term. So LF choice is equal to 2. We're going to use that same variable term. And so now we're going to say it's equal to input of what term do you want to add? And so now we're going to do the same thing we did up here. We're going to check to see if it's in our list already. Because if it's already in our list, we don't need to add it in. So if term, and here we're going to do something a little different. You're going to say not in geek. So what you're checking for is if it doesn't exist, then you're going to say, we're going to use definition, and you're going to ask that from your user, so input definition, please. So now we're going to get a definition, and so now we can say geek with the value of term is equal to definition. So we created a new one. So else, so if that word already exists in our list, we can say print that term already exists. So now we can run this again. We can check and see if that function works. So we're building it, and then we can figure out where our errors happen to be. So I know that 1 works, and so now we're going to add 2. We're going to add a geek term. And so what's a geeky term? What have you guys heard that's geeky? What's a geek term? Man, we use them all the time. So let's just put in a made-up word. So I'm going to define the word flipper. And definition, please, the appendage on a dolphin. So now I have an error of some sort. So it took my inputs, and then it said geek term equals definition. So clearly I did something wrong. And my guess is, when I look at this, that I did not spell definition the same. So let's do this. I can't hardly see on this screen to always make it more fun. Let's just paste it in and make sure that they're the same term. We can try it now and see if that's the error. Define a geek term. What term do I want to add? 303. Is a number. So we're getting an error that says definition is not defined. So somehow in there I've got an error in terms of spelling. I've done something really odd. Geek term, input, definition, what have I done? Alright, term not in geek, definition equals input. So I'm going to do a little error checking here, so I'm going to put a pound sign in front of that line. And now I'm going to run it and see if it's that line that's causing me my problem. And it works, so it's somewhere in this particular line that I've got an issue. So what could I have possibly done other than I did not type that correctly somewhere? All right. So if I spell it right, magically it should work. And notice there it does. So it actually adds it in, and I could actually now look that up. And 303 will say, yep, I just entered a number in there. So again, that spelling really is important, making sure that those variables are the same name. A lot of times, like I said, I do the cut and paste, and it's hard to see if you guys ever come into the lab and you look up at this monitor, it's like some fuzzy, because it's at a different definition and screen resolution than the monitors. So we can do those pieces. So we will start out on Thursday. We'll show you how to replace terms, and we'll actually build our hangman game using a dictionary and a lot of word art. So we can actually build a game of hangman. You guys have got those skills. Your challenge this week for your assignment, so you're going to program that prints out a list of 15 words in a random order and not repeat any words. So it's going to grab 15 words, random order, not repeat any. Then you're going to add the ability for the user to enter new words, okay, kind of like we do here, and display the list. So you need to be able to do that over and over again. So we're working on that idea of scalability. So if we go from 15 words to 30, it should still be able to put them in and not repeat any words. When you allow your user to enter a word, it needs to make sure that that word doesn't already exist in the list. So there's a way you can do that. So it sounds simple, but it takes a little bit of creativity to get this to work correctly. All right, there is also a discussion board this week. So the discussion board this week, for week 11, and it's out of order for some reason, I don't know why. So this week, you guys are going to publish your code that you did last week. So in other words, your code that you did the last week, you're going to publish. What you are going to do then is you can look at what other people have done and you can comment on that. You could say, Ah, yes, I want to see if I can do that. What I would recommend, because sometimes when you cut and paste into this, it will skew this, is I recommend you actually do two things. You cut and paste in your code so people can see it easily, and you attach it as the .py file. So that way somebody can grab your code and run it and try it. And so what you're going to do is you have to do at least 2 students, but you're going to go through and assist them and look at, hey, you could have maybe done X and that would have led to a better scalability. So it's a way that you can look at your code, look at others' code, and you can actually get a little helpful hint as we go through here. So we're going to do those through the rest of the semester. Now, there's a little bit of a double-edged sword on that. If for whatever reason you don't submit code to the assignment, you're also losing points then on the discussion board. So if you choose not to do the assignment for some reason, you also have an issue with the discussion board. Now, you can get some of the points by good comments on other code or now analyzing it, but you're not going to have that original post, unfortunately. So just be aware that while this is a great way to learn how to code and look at things, it also gives us an issue. The second piece of that's an issue is if you don't turn in your code on time. So you're going on a trip, vacation, something else, you don't turn it in on time. Monday, everybody starts submitting their code that they've already done. That's part of the reason we can't take any late assignments. If you really are in a hospital, laying there with a broken leg and can't get to campus something, I will give you an alternative assignments, but I can't give you the original assignment. All right, let's get out of here. Hopefully it gets a little warmer today. It's supposed to get up to 50. It'll be great.